Odds ratio. Curious about how to calculate the odds ratio? Well, that's exactly what we'll show you in Part 5 of our series on statistics. We previously had a look at the relative risk. Although similar yet different, the odds ratio is also a measure that quantifies the strength of the association between two events. To understand the odds ratio, let's start with an example. Do you remember our fictional study from the previous episode? Well, let's enter the values in a table. 100 smokers and 100 non-smokers were monitored. Of the 100 smokers, 20 developed lung cancer, whereas the remaining 80 didn't. In the non-smokers group, 2 individuals developed lung cancer and the remaining 98 didn't. Let's first calculate the relative risk of smokers compared to non-smokers. If you'd like, pause the episode and give it a go. So, what value did you come up with? The relative risk is obtained by dividing the risk of smokers by the risk of non-smokers, that is, 20 divided by 100, which is 20%. The risk of non-smokers is 2 divided by 100, or 2%. So the risk of smokers developing lung cancer is 10 times higher than the risk of non-smokers. Now, let's look at the odds ratio. Calculating the odds ratio is very similar to that of the relative risk. All you have to do is replace the risk value with that of the odds. You divide the odds of smokers by the odds of non-smokers. So how does it look when using actual numbers? You obtain the odds of smokers by dividing the number of diseased individuals, 20, by the number of healthy individuals, 80. This is also applied for non-smokers, which is 2 divided by 98. As we explained in the previous Chalk Talk episode, odds are usually expressed as a decimal or whole number. 20 divided by 80 is 0.25. 2 divided by 98 is approximately 0.02. In this case, the odds ratio is 12.25. Therefore, the odds of smokers is 12.25 times higher than the odds of non-smokers. Okay, so now you know how the odds ratio is calculated. We'd like to now compare the possible range of values for the relative risk and odds ratio. But before we do that, let's quickly recap the range of values for the risk and odds. In the last episode, we showed you that the risk is calculated as a proportion. You divide the number of individuals with the disease by the total number of individuals. A proportion can only be specified as a value between 0 and 1. In contrast, the odds of developing the disease is calculated by dividing the number of individuals with the disease by the number of individuals without the disease. It can assume a value greater than 1. Let's now turn to the range of values for the relative risk and odds ratio. Interestingly, the range of values for both are identical. Both can assume values between 0 and infinity. A relative risk as well as an odds ratio of 1 means that both groups have the same risk or odds of developing the disease. In other words, exposure doesn't influence disease occurrence. If the relative risk or odds ratio is greater than 1, the disease occurs more frequently in the exposed group. If both are between 0 and 1, the disease is rarer in the exposed group. The latter occurs when exposition has a protective effect. At this stage, there's something very important that should be mentioned. Although the relative risk and the odds ratio have the same range of values, they sometimes deviate more and sometimes less from one another. As you've already seen in our Chalk Talk episode on odds, the risk and odds are almost identical for rare diseases. The same can also be said for the relative risk and odds ratio. For rare diseases, the relative risk and odds ratio values are almost identical, yet the more common the disease, the more they differ. Okay, so that was our introduction on how to calculate the odds ratio. You're probably wondering where the difference lies when it comes to applying these two measures. When is the relative risk used and when is the odds ratio used? We'll be discussing this in Part 7 of our series on statistics. Before we do that, we'll show you some tricks used to calculate the odds ratio in Part 6.